I'm formerly a co-founder of Muse Games, and I directed Guns Online from its design document through its launch last October. Before I get too far into this, I want to note that Muse Games never would have happened without Unity. All of us at Muse Games started our professional game development careers with version 1.6. We go way back with some of those guys. I think we're infamous with their QA team at this point. And we learned everything as we went. So none of this would have been possible without Unity's vision for democratization. So to any Unity guys here, I want to say thanks. We're truly the beneficiaries of your hard work. So, like everyone at Muse, on Guns Online, I wore a lot of hats. I was an engineer, I was lead game designer, and a producer with too many responsibilities, which is to say, a terrible producer. But game designers believe players learn the most through failure, so I have a lot to talk about. These views are my own and do not represent those of Muse Games, which is probably why I no longer work there. Today I'm going to talk about how small teams with impossible ideas can find ways to succeed. I'll be doing this through the lens of the 3-year development of Guns Online. This talk isn't so much a deep dive as a tiny 1,000 steps, which when taken together forever change the way we all think about game development at Muse. I hope by the end you're all inspired to reflect on your own development processes. But first, what the hell is Guns of Icarus? So, primarily, Guns of Icarus Online is a sequel. The original game launched in 2009. It was built by 5 of us in under 4 months. Made in Unity, obviously. It had co-op multiplayer and was one of the first games any of us had made. It launched on the web. We eventually ported it to Steam, and it garnered enough of a cult following among hardcore steampunk fans that some publishers approached us with more money than any of us had ever seen and asked us to make a much larger game. And near the middle of 2009, they asked us to make Guns of Icarus Online. And if the online name evokes MMO, it's because it had the 130-page design document to back it up. Looking back, based on the features we agreed upon on this design document, it should have been about 300 pages long. Just in this table of contents, we had 5 pages dedicated to ship customization and 1 dedicated to database structure. Off to a good start. I think it's important, before I move too much further, that I highlight a few of those features so you understand just how screwed we were. Real-time cooperative multiplayer combat in an open world with customizable ships, players, and skills, a market economy, complete with trading and auctions, player-created towns, procedural missions, and a monetization model that would work in Eastern and Western markets, and boss battles that looked sort of like that. For all of this, how much did they offer us? Guesses? Anyone? Yes! So I'm not sure if it was hubris or excessive exuberance or what, but we said, yeah, let's do it. What could possibly go wrong? After all, we just released Kehrer, our first puzzle platformer, biggest game we'd ever made, launched on iOS, got decent reviews. It took about a year. We sure looked happy. Ignorance is bliss. I think at the time we all knew we were completely screwed, because everyone started getting a little snappy at the mention of the word MMO. We all knew it took millions of dollars to build MMOs, but this wasn't an MMO, right? Definitely not an MMO. I mean, no way. 3 years later, we shipped Guns of Icarus Online. Here's the game. So now, how did this impossible project manage not only to release, but win some awards and develop a thriving online user base? Yeah, we all worked really hard. There was a lot of beer, meager living conditions, but we also changed our strategy. So really, the name of this talk is Digging Guns of Icarus Online Out of a Very Large Hole. Hopefully, if you're ever in this situation, very quickly you realize your mistake and you correct it. We did the opposite. We all worked harder and coded faster. We coded tired, we coded drunk. We managed to meet the first 9 months of milestones, but we had a huge problem. In addition to all the engineering debt we'd piled up by hacking features together, the game sucked. And ordinarily, if you find yourself in this situation, it's game over. You have a game that sucks, you have an unmaintainable code base, and you're running out of money. But many thanks to our CEO, he managed to find us some private investments. Our original investors doubled down, taking most of the equity with them. And we had a hard 18-month deadline, a useless code base, and a pretty burnt-out team. But we still had a vision for what we wanted this game to be. No one survives alone. It was our #1 design principle and guiding pillar. We wanted to build a game, much like the first one, where cooperation was paramount, not just tacked on. So we had nothing left to lose. We threw out the milestone sheet, we threw out the feature lists, and we decided to regroup. We were too small to follow traditional game development practices. We were a team of between 10 and 20 people at any given time, not 100. So why did we copy their structure? We didn't even know what this game was going to be yet. So how can you start integrating, Facebook before the core experience works correctly? So this was our new design philosophy. We're going to focus on fun, never features. We treated ourselves like scientists doing primary research, which meant I would tell people, I can't promise you a schedule. I can't promise you deliverables. All I can promise is we'll make the best product we possibly can. We're going to fail a lot, and we're going to fail quickly. The trouble with saying this is business people hate this shit. It's completely unquantifiable. It sounds like a party with their money. So how do you justify it? I think 3 years ago, if I could have written the next 10 slides, those 9 months of hell never would have happened. Even if you're working on a fairly well-defined game, fun is fundamentally an unknown quantity. It's highly multivariate, and it has no closed-form solution. Everyone on the team needs to recognize that no one knows exactly what fun is. Game designers are employed to create experiments and detect fun, not like pull it out of a hat. So if that's true, and I think many of us can agree that that's true, running more experiments will improve the overall quality. We can sort of do a Newtonian method to find fun. So if we're finding fun iteratively, how about we optimize our entire company for iterating as quickly as possible? But how do we do that? Who makes decisions? How do we approach a target rather than running a million different experiments for whoever wants to do what? And how do we convince the money people that we're not out back smoking bowls all day? It turns out there's a well-defined methodology specifically for talking to management and maintaining focus while iterating quickly. Many of you are familiar with this. It's called Agile. And while the software engineers in the room may be familiar, I know a lot of you aren't. I'm not going to spend too much time on this. There are plenty of good resources out there, and if you haven't heard of it, you should read up. But I want to address the core philosophies of the Agile development process, and then you'll get a better understanding of how we reshaped our team to achieve those goals. First, Agile is a framework for rapid development of maintainable software. The goal is to get the product in a releasable state as soon as possible and keep it that way while you incrementally make improvements. It relies on frequent iterations, typically 2 to 3 weeks between functional release-ready builds. This was in contrast to where previously it was 3 months when working with a publisher before we had check-ins. A lot of people say, yeah, Agile, everyone knows that. But when I've talked to people, very few people actually follow release-ready. And by release-ready, I mean actually releasable, as in all of the functionality that is included has UI, works as expected, and is complete. I mean, think about what that means and how much work that actually is. Additionally, the product team is open to changing requirements, which is good, because since at the beginning we all agreed we don't know what fun is, we actually don't know what we're making yet. It has airships and guns. Sustainable pace. While working in an Agile framework, you maintain a sustainable pace. This is mostly a function of keeping the product release ready. The most frequently when I've seen bad crunch times, it was because functions made it into builds either without real UI, half implemented, or just completely broken. If you're following an Agile process, that isn't allowed. As a consequence, you very quickly develop realistic expectations about how long a feature will take. Simplicity. There's an emphasis on simplicity. The buzz phrase here would be minimum viable product. For a game, that's probably the fun part, unless you're designing a free-to-play game in which it's probably your monetization loop, which in its own evil way is the fun part. And co-location, which means your whole team is in the same room, communicating face to face. So here's what a standard 2-week dev process looks like. At the beginning, you look at your entire feature list, decide what you want to test, and prioritize them at the top. You'll never achieve your entire list in any sprint. That's OK. After that, you develop as many of those features as you can, test them, and then integrate them before the end of the 2 weeks, and you release a build. Then you repeat. When you're trying to refine ideas quickly, what could possibly be better than Unity? How much can you guys accomplish in 2 weeks? It's a lot. But Agile's just a process. It's a starting point. To make this work, you really have to commit your entire team to the idea that more iterations will yield a better product. And that's exactly what we did. So here's a fairly standard representation of what a team might look like. This is our team. And it's also a gross misrepresentation of team composition. It's what we're all accustomed to seeing. I mean, we could segment this further into specialized roles, subcategories, graphics engineer, network engineer, lead artists, et cetera. But that representation's a holdover from prioritizing efficiency. Ever since, the Industrial Revolution, efficiency's meant the specialization of the workforce, the alienation of labor from product, if Marx is your thing. Here's a fairly standard definition of employee efficiency. How many units of service a person makes per amount of time. OK. Well, artists make paintings. Designers make Google Docs. What do software engineers make? Of course, the answer is code. If you cram enough of them in a room, eventually a game comes out with the requested features, right? No, stop that. The new unit of service is a testable iteration. We don't care about code. We care about how many iterations you can make, and we care about speed. Which means now I care less about how many artists, engineers, and designers I have. I want a highly cross-functional team. I want people that can work together quickly to solve problems. I want to be able to iterate on designs many times a day. I want everyone on the team to test their own assets. I want play mode in the editor to always work and never break with compile errors. And ultimately, I want a fun game. Why cross-functional, you ask? Aren't specialists faster? The answer is, of course, yes. Specialists are faster. But the problem is, small, highly cross-functional teams may be linearly less efficient than highly specialized teams, but they can iterate exponentially faster. And why? Resource bottlenecking. If one person on your team can hold up the entire iteration cycle, you have a big specialization problem. For a while, we had serious specialization problems. In addition to everything else, I was integrating all of the art. It would take weeks for me to integrate all of the latest art, at which point there was new latest art. It should have taken me hours. And that was dozens of iteration cycles lost. And then one day, one of our artists came up with the idea, well, what if all the artists could just integrate their own stuff and their own assets? And some of our engineers said, well, that would mean, getting you guys into SVN. That's never going to happen. And then I said, well, wait a minute. What if you engineers stayed out of the command line for a minute and built visual tools? And what if the animators understood the game design constraints? OK, well, that sounds great, but how do you teach everyone that? And this is why I'm so big on co-location. Co-location improves shared learning through at the very least, osmosis. Even better, impromptu meetings, free discussion, people cursing in the office about the latest broken feature. And as the team scales, it becomes a little chaotic. So you end up in engineering groups and art groups. But you can counter this. We moved people around. We sat artists with engineers, designers with artists, et cetera. But most importantly, we instituted a few rules. 1, everyone uses version control. I mean everyone. Artists, it's now part of your job requirement. Engineers, if you can't get out of Vim to learn the faster GUI tools, how can you expect to communicate with the rest of the team? So it goes both ways. We love the engineers that are command line wizards, and there are really days we need your skills to save the repo, but most of the time, keep it in your pants. Artists integrate their own assets. This seems obvious, especially if you're working in Unity, and we were really, I don't know when we got away from this, because at first it was really pretty core. Unity's great at this. You have a natural advantage that I think a lot of people don't take advantage of when they start to scale to larger teams, but this is what makes you fast. This is how you can compete against much larger teams. If you go to talks by EA or any of those guys, they talk about their art integration pipelines, and they sound like a disaster. For us, once we got everyone integrating their own stuff into SVN, it takes minutes to write a scriptable object or custom editor to get even the least technical artist to be able to integrate their own stuff into Unity. And just those simple tools are great because you can sandbox members of your team who you really don't want touching your project files at all. Daily Scrum, this is another core tenet of Agile and also really important. Everyone hates meetings. But a daily stand-up at the beginning of the day with the entire team, not just engineering, is critical. Everyone's present, everyone talks about what they're doing, it's capped at 10 minutes. Here's what one person might say. Yesterday, I integrated the character jump animation. Today, I'm adding IK to the land animation. But I'm blocked until you make changes to the rig. Let's discuss it after Scrum. Done. That's it. Now everyone knows what everyone else is working on. It took 10 minutes. 4, dedicating time to learning. This is another one of those things that, sounds like some hippie stuff that business people tend to balk at a little bit. But understanding the value of this is critical. Our engineers used to do most of the particle work. Particles are kind of technical. There's some physics there. And the thing was, our artists always hated what they came up with. The artists also happen to never make the textures correctly. So we share some knowledge, and everything gets better. Now the artists make all the particle systems themselves. Engineers are free to make tools again. The amount of knowledge that can be shared is incredible, and it's great for morale. 7 years ago, I was a film major who never coded anything. Today, I'm lead developer. That's not an accident. And I want to drive this one home. Engineers overseas can be tempting, especially for the MBAs in the room, but only if you're still measuring code output. Measured in iterations, outsourcing reduces efficiency by an enormous amount. We're talking orders of magnitude. And you've lost any shared learning benefits. All of those impromptu conversations, that recent bug in the beta version of Unity that you just discovered, they don't know about it. How are they going to know about it? Who's going to write those emails to your team overseas? No one's going to do that. Are you going to do that? Really? In my opinion, outsourcing, whether it be local or across the globe for whatever reason, is, at least on small teams, small agile teams, a failure of management to understand what your real bottlenecks are or how games are made. If you start an entire team overseas, that's another story. That can work, obviously. The result of all of these optimizations is burst capacity. It's the ability for people to transition to roles where they're needed. It's like acceleration versus top speed if you play a lot of racing games. We want acceleration, not top speed. So all of this is pretty awesome so far, but it hinges on one thing. And it's something a lot of game developers, myself included, don't really like to hear. And that's software architecture. We need architects, not programmers. Now that we're agile, we're releasing a new version every 2 weeks, and we're constantly refining the concept out from under the production. If you aren't disciplined, your code becomes a house of cards very quickly. At the same time, designers need to rough out ideas without worrying about which design pattern to use or arguing about whether the model can force a view change. So to facilitate this, we made gray box prototypes with hacked together code. Again, we remembered, hey, Unity's pretty good at this. Why don't we take advantage of that? Just kick open a new Unity project. The code will never see production. If people like it, we'll spend some time and architect it correctly. Unfortunately, there's still one weakness with this. Because we're targeting releasable iterations, as I mentioned before, the UI still changes a lot. And as you know, UI in Unity is unpleasant. Worse yet, UI is where Agile really broke down for us. This wasn't as much a problem with Unity. We wrote custom UI libraries. It took a little while, but after that it was fine. It was more an indication of server-side state colliding with client-side state, and it was just very complicated. Changing functionality became very hard. Even setting it up once was hard. We set up quick layouts, but it didn't go far enough. We didn't abstract state as much as we should have. And the result of not architecting this quite correctly at the beginning is that in the end, the UI isn't quite up to our standards. UI isn't always the bottleneck. It might not be the bottleneck in our game, in your game. It wasn't ours. The key here is to try and identify those bottlenecks early and definitely devote some architecture and tools time to solving those so that you can iterate quickly. One example where we did do this, we identified our Java server as a serious engineering bottleneck, in large part because our engineers were constantly thinking in two languages. They were jumping between C# and Java, and those context switches take time, and they're expensive, and they result in bugs. So we switched to Photon and C#. We spent about 3 months reporting all of the code from Java to C#, as well as writing wrappers to wrap up math libraries, PhysX, and a scene graph to mimic Unity. At the end of this, we could port code directly from the client to the server. This was awesome. We could now, again, use Unity as a prototyping tool and then just dump that code on the server once we were happy with it. Or we could, compile things into common libraries and use it on both. This massively reduces the number of bugs you have to track down and keeps all of your engineers happy. In terms of design, we pushed for completely data-driven configuration, all from the Unity editor, no engineers required. For example, our weapons. This is a smattering of weapon parameters that our designers could tweak and push to the testing database immediately and unassisted, directly from the Unity editor. So, for example, our designer could sit down, decide he wanted to change the AoE damage on the flak cannon. Do so, push a build, 5 minutes later, he'd be testing. This speeds up design iteration by a huge amount. We also based our core systems on physics rather than our hacky prototype code. This took a lot of work, but it pays off when your designers have an intuitive understanding of the underlying system. So for example, here's our rough flight model. I originally hacked something together, but at the advice of one of our engineers, we redesigned it. This is so simple, it's obvious. Of course, re-expressing the desired behavior this way took a lot of work, but it paid off and eventually allowed for much more complex behavior later and kept our code base very simple. So, our engineers acted as tools developers, helping the rest of the team perform experiments more quickly. And of course, they architected the fundamental library interactions and network transport layers. As with any group of engineers, we had a variety of philosophies, from the lone gunman from scratch hardcores to the bros who just wanted enough code to glue libraries together. We ended up taking a middle route, using only the libraries that were well maintained and documented. Even then, we rewrote a large number of features, but that was basically our entire technology stack. And finally, of all these things, we had to take a look at our product. With Agile, we had a good process for doing so. We picked a single core experience, a competitive multiplayer game featuring cooperative collaboration. That's it. We cut 2/3 of the features, and we did it bi-weekly, since certain features kept rising to the top. Yeah, fixing networking bugs is still more important than being able to paint your ship orange. Open world is cool, but it's not core, and it's going to take 2 months. Economics, cool, not core. We'll come back to them later. And we finally started using Unity for its core strengths again. Our entire team was working directly in Unity, every artist, every animator, integrating their own work. This massively reduced bottlenecks. Ultimately, the most important question was, were we able to make a fun game? Here's some of our players.
One of them Shoot that ship. Simon, climb this ladder.
Starboard. Hard starboard.
Okay.
Man the guns.
I'm taking us up. Get on the guns and shoot that guy.
Shoot that ship, Simon. Shoot it.
It's far away.
I think so. I think it was fun. And I worked on it for 3 years, and I never want to see it again. So, summing this up, we took a project that was naively planned, doomed to failure, and turned it into something that not only shipped, but is enjoying a reasonable measure of success. Yes. Woo! This owed not to any miracles. We had a very hardworking team. As I mentioned before, our CEO went out of his way to keep the team alive. Without that, it never would have happened. But it's largely because we changed our direction and optimized our workflow for iterative development. We changed our process, we changed our structure, we changed our metrics, and we also changed ourselves. And Unity was right at the center of that. So thank you, and good luck.